Let us have number 5. Limit of square root of x as x approaches 1/4 is equal to 1/2. So here, a is equal to 1/4 and L is equal to 1/2. So given any epsilon that is positive, we need to find a delta that is positive such that if the absolute value of x minus a, so our a is 1/4, is between 0 and delta, then the absolute value of f of x, that is square root of x, minus L, so L is 1/2, is less than epsilon. So to be able to prove this, we need to find a delta. Find a delta, an appropriate delta, and to find that, we consider this conclusion. So that's the technique. So absolute value of square root of x minus 1/2. So our goal is to come up with absolute value of x minus 1/4 out of this. So in order to get that, we multiply absolute value of square root of x minus 1/2 by the conjugate, both the numerator and denominator. Okay, guys? So we have absolute value of square root of x plus 1/2 over absolute value of x plus 1/2. Okay? And this is equal to, so the numerator, when multiplied, we have absolute value of square root of x minus 1/2 times square root of x plus 1/2 all over square root of x plus 1/2. Absolute value of this. Actually, this absolute value is immaterial because this radical is always positive for all x that is in the domain of square root of x. Or 0, no? That is positive or 0. And when simplified, the numerator is equal to absolute value of x minus 1/4 all over absolute value of square root of x plus 1/2. So again, because this square root of x is always positive for all x that is greater than or equal to 0, that is the domain of square root of x. So it is all right not to put the absolute value. And this is equal further to absolute value of x minus 1/4 all over square root of x plus 1/2. Okay, guys? So if I'm going to drop the denominator, this part in the denominator, I mean, this square root. So this is simply equal to what? Or greater than. If you drop this square root of x, the denominator gets bigger. The denominator, if you drop square root of x, gets smaller. So if the denominator gets smaller, this fraction now gets bigger. So once I remove this radical, I get now a fraction that is getting bigger. Okay? So this is now greater than or equal to what? Absolute value of x minus 1/4 over 1/2. Again, dropping this square root of x, if we remove this, so this denominator now gets smaller, and the smaller the denominator, the bigger the fraction, because we retain the numerator. Or equal, no? Technically speaking, can be equal when x is 0. So this expression is equal to this. Okay? Now, square root of x minus 1/2 abs of this is equal to this expression. And this equal and also equal to this. Now, since I want this to be less than epsilon, let's force this right side. Force this to be what? Force this to be less than epsilon. Because if this is less than epsilon, and we know that this is greater than this, so it means this is less than epsilon, and it follows that this is also less than epsilon because this is equal to this. So we left absolute value of x minus 1/4 over 1/2 to be less than epsilon. So if this is less than epsilon, then we say that the absolute value of x minus 1/4 is less than epsilon over 2. Okay, guys? 1/2 times epsilon. Hence, we can take our delta to be epsilon over 2, or any delta less than epsilon over 2. So you can consider any delta that is less than or equal to epsilon over 2. So, but let's take, for convenience, epsilon over 2 to be the delta. Now, but we have to take note that this is radical, and a radical has values of x that can make that radical undefined. And our fear is that if we assign a value of epsilon, we might have an interval to contain what? An open interval to contain those values of x to the left of 0, which is not which are not in the domain of square root of x. So it's all right for if epsilon is small. What if epsilon is, let's say, 2? If epsilon is 2, 2 over 2, delta is 1. And if I add 1/4 to delta, I mean, 1/4, I add delta, 1/4 plus 1, then 1/4 minus 1, I will have an open interval that can contain those values to the left of what? To the left of 0. And if x is to the left of 0, this radical is undefined. So we have to have another restriction for delta. So let's draw a number line to make sure what maximum delta we can take. So from here, so let's say this is 1/4. And if I add 1/2 and subtract 1/2, I will what? I will get an interval that will contain to the left of 0. So I think maximum is just 1/4, no? Because if I subtract 1/4 minus 1 from 1/4, I will get 0. So the interval safe to the maximum open interval safe to contain 1/4 and will not contain more than, less than 0. So by adding and subtracting from 1/4, 1/4. So this is now, so 0. So we have the open interval here up to here. And this is 0. And this is 1/2 after adding. So this is 1/4 plus delta. This is our 1/4 minus delta. 1/4 plus delta. 1/4 minus delta here. Okay? So, and we have -1 here. So all values to the left of 0, all values to the left of 0, x here is no longer element of the domain of square root of x. Those that are to the left of 0. Okay, guys? Here, x is what? Less than 0. Okay? So that means the delta that we can take, the maximum delta that we can take, 1/4. So at most, 1/4. So as additional restriction to delta, I can take, for convenience, take delta to be equal to 1/4. Or you can have it also 1/8, 1/6, 1/7, as long as less than 1/4. Of course, greater than 0. No? So again, or any delta that is less than 1/4. Okay? So this is the maximum delta that I can take, safe, so that we will not able to cover those x values, making the radical that is square root of x undefined. So these two restrictions on delta can be written minimum of 1/4 epsilon and epsilon over 2. Okay, guys? Yeah. So we are now ready to prove formally the limit, the condition, no? So the if absolute value of x minus a is between 0 and delta, then the absolute value of f of x minus l is less than epsilon. So show that. So this is our formal proof. Delta equals minimum of 1/4 epsilon over 2 works. So from the hypothesis, we have absolute value of x minus 1/4 is less than epsilon. Less than delta, I mean. This implies that the absolute value of x minus 1/4 is less than epsilon over 2. And we have, for the restriction on we have square root of x, 1 over square root of x plus 1/2. This is less than 1 over 1/2, or this is equal to what? Which is equal to 2. Okay? So we have let me check if I'm correct. So we now have here absolute value of x minus 1/4 times 1 over square root of x plus 1/2. If I take the absolute value of this, is still the same. And this is less than epsilon over 2 times. So this is less than epsilon over 2, but this one is less than 2. And this left side is x minus 1/4 absolute value over absolute value of square root of x plus 1/2. Okay? So from here, this is epsilon. And we know that this left side, from what we had in our previous solution here, this is equal to what? Equal to this or to this. So hence we say that this left side is the same as is absolute value of square root of x minus 1/2. And this is less than epsilon. So we have shown that f absolute value of x, f of x minus l is less than epsilon. Therefore, we say that the limit of square root of x as x approaches 1/4 is equal to 1/2. Okay, guys? So that ends that proof. So let's have number 6. Limit as x approaches 1 times of square root of 6 minus 2x is equal to 2. So here, a is equal to 1 and L is equal to 2. So let positive epsilon be given. Okay. Okay, guys. So we want to find a delta that is positive such that if the absolute value of x minus a, so that is x minus 1, is between 0 and delta, then the absolute value of f of x, that is square root of 6 minus 2x minus L, so L is 2, is less than epsilon. So to prove this, first we need to find an appropriate delta. And again, the technique is to what? To consider this conclusion. Note that square root of 6 minus 2x minus 2, take the absolute value of this difference. This is equal to. So again, the technique again, to come up with absolute value of x minus 1 less than delta, we rationalize this by multiplying the conjugate of this expression inside. So that is square root of 6 minus 2x plus 2 all over square root of, so absolute value of that is square root of 6 minus 2x plus 2. And this is equal to, so the product of this and the numerator here is absolute value of 6 minus 2x, then minus 4, all over, because abs times abs, so we multiply the expressions inside, and that is 6 minus 2x minus 4 abs of this, and that is over square root of 6 minus 2x plus 2 abs of this. But this is equal to abs of negative 2 x minus 1. Let's check. Negative 2x. So we have here negative 2, negative 1. That is positive 2. 6 minus 4 is positive 2. All over abs of square root of 6 minus 2x plus 2. Okay? And this is equal to 2 times abs of x minus 1 all over square root of 6 minus 2x plus 2. Actually, this absolute value is immaterial because if x is in the domain, the value of x is in the domain of this radical, this is always greater than or equal to 0. Okay? So if I remove this radical, the denominator here becomes smaller. And the smaller the denominator, the bigger the fraction. If you have the same numerator, okay? Or equal to, if this is 0. So I can cancel 2 to get what? To get absolute value of x minus 1. Okay? So I think I need to copy this so that I can see this when I move to the next slide. Let me copy here. So this is the last line that I have. I can still simplify this, right? And this is equal to what? Abs of x minus 1. Am I right, guys? Yeah. And this is what this is supposed to be less than delta. No? So, meaning, actually this is what? This is less than epsilon, I mean. But since I have this, this might be greater than this. So let's force this. Because this is greater than this. And we know that this is equal to this original left side of the conclusion. And for this to hold, for this to be less than epsilon, let's force this to be epsilon, less than epsilon. So we let what? We let absolute value of x minus 1 to be what? To be less than epsilon. Okay, guys? Therefore, our delta is equal to epsilon. Okay, guys? So again, then we can take delta to be what? To be epsilon. So again, take note that this is greater than this. And this is equal to the left side of the conclusion in the statement we are supposed to prove. So the left side of the statement we are supposed to prove is equal to this. And this is supposed to be less than or equal to this. So, and for this to be less than epsilon, because you want the left side of the conclusion to be less than epsilon, let's force this to be less than epsilon. If we force this to be less than epsilon, then this is equal to what? I mean, this is less than epsilon. So I can take delta therefore to be what? To be epsilon. Okay, guys? Yeah. So again, this implies that let me check this. So for you to understand well. Then we now have absolute value of what? Absolute value of square root of 6 minus 2x minus 1. Sorry, minus 2. Is that minus 2? Minus 2, right? Which is equal to I mean, which is greater than, less than or equal to absolute value of x minus 1 but we force it to be less than epsilon, this, so this is less than epsilon. Okay? Yeah, for you to clearly see. So again, take what? Take delta to be epsilon. As usual, you can take any delta to be less than epsilon. So if epsilon works, for sure, epsilon over 2 will work. But take note, we have other restriction for delta, no? So hence, delta is equal to what? Minimum of what did we take? By the way, so we have one restriction pa lang, no? So we have just one restriction, I think. Let me check. How many restrictions we have already? One. So let's now bound this denominator, no? Yan. Let's bound that denominator. So we want, remember we want our x to be what? To be in the open interval 1, that is our A, no? Am I right? Our A is 1. 1 minus delta, 1 plus delta. Okay? So let's draw. Because that is radical, we might, our fear is that we might cover in the interval once we choose our, or once we stipulate our delta, we might include values of x that will make the radical undefined. So that's our fear. So to make sure, so let's choose a delta that will guarantee that we will not able to cover x values that will make the radical, our f of x, undefined. So this is our number line x. And our center is 1. This is our A. So we have 1, this is 0, this is -1. If you have square root of 6 minus 2x, the domain of this is what? 6 minus 2x, the domain is greater than or equal to 0. 6 minus 2x greater than or equal to 0. Okay? Or 6 is greater than or equal to 2x. Or divide by, so 3 is greater than or equal to x. Or x is what? Less than or equal to 3. So we try to avoid those values that are to the right of 3. So to the right of 3, this is 2. This is 3. So meaning, we can have our delta from the center up to what? Up to a maximum of what? Of 1, 2, no? At most 2. Because if I add 2 to 1, I will get 3. So the maximum interval, open interval that we can have containing x equals 1, although we do not want x equals 1, but containing x equals a, is what? Is this interval. Okay? Up to this. So meaning our delta is what? 1, 2. So at most 2 units away from 1. So that's the maximum delta that we can take. Is that clear, guys? Because, so again, I can take this delta. This is my delta. I can take this part. I think I got the wrong, sorry. This is up to what? Up to negative 1. No? Yan. This is the maximum delta that we can have. That's the maximum. So that is delta, delta. And of course, any delta less than that will work. So hence, delta can take at most what? At most 2. For convenience, which is actually our actual goal, because we want delta to be small. For convenience, let's take let's take 1. Delta to be what? To be equal to 1 for convenience. Can I take 2? Yes. Can I take 1/2? Yes. After all, we just want a delta, and that's what I want. And of course, if you take delta to be 1, any delta that is less than 1 can be chosen. Is that clear, guys? So our restriction, delta, is now equal to the minimum of what? We have 2 restrictions now. Minimum of 1 and epsilon. Okay? Minimum 1 and epsilon. So coming from this restriction and another restriction. So let's see if the chosen delta works, which is equal to the minimum of 1 and epsilon. So it means if I choose epsilon to be 1/2, I choose delta to be 1/2. If I choose epsilon to be 2, so if epsilon I mean is 2, so I have to choose 1 because it's smaller of the 2, whichever is smaller. If epsilon is 8, so I have to take 1, so that I will able to what? To be always within the chosen interval, or to be within always that interval, the open interval. So I must choose minimum of the 2. Okay, so let's now prove let's have a formal proof. We know that abs of x minus 1. That's right, no? Abs of x minus 1 is between 0 and delta. So that's correct, okay? So this implies that abs of x minus 1 is less than epsilon, that is my delta. And also, I have delta equals 1, which implies that 1 over is square root of 6 minus 2x, that is what I got from delta equals 1, plus 2 is less than 1/2. The bound for this, no? Okay? Or the absolute value of this. So if I multiply this by abs of x minus 1, actually I can have it abs, no? Because after all, that is just simply, they are just the same. But we need actually, what we need is absolute value. But we do not have to worry about the value. The square root of 6 minus 2x plus 2. That's just the same with this. So this absolute value, if I multiply by this fraction, abs of x minus 1, this is less than epsilon, times a fraction that is less than 1/2, that is 1 over abs of square root of 6 minus 2x plus 2. This is less than epsilon times what? Times 1/2, right? Okay, guys? Guys? Okay, so let's multiply this by 2. Let's multiply by 2. Because what I want is this, no? Remember, our goal is to have 2 here. And this is equal to what? 2 is absolute value of square root of 6 minus 2x minus 2. So I multiply by 2 to get 2 abs of x minus 1 all over abs of square root of 6 minus 2x plus 2. And this is less than 2. I multiply also the right side, epsilon over 2. And this left side is, we know that this is abs of square root of 6 minus 2x minus 2. And that is less than epsilon. Clear, guys? So remember, this is what? So I have here this. Yan. If I put absolute value, that is the same with this. And we know that this is equal to what? From our previous solution here. So this is equal to, exactly equal to this. And if I take the absolute value, that is equal to this. And we know that this is less than epsilon. Okay? Which is equal to this. So therefore, we now conclude that the limit of what? As x approaches 1 of square root of 6 minus 2x is equal to 2. Okay, guys? So that's it. Since we have shown that the absolute value of f of x minus L is less than epsilon, so we're done. So the limit is really equal to 2. So let's have this last example. So we now have number 7. Limit of 28 over 3x plus 1 as x approaches 2. This is an exercise in one of the books written by Vivens. So it is equal to 4. Again, the limit of 28 over 3x plus 1 as x approaches 2 is equal to 4. So our a here is equal to 2. Our L is equal to 4. Solution. So again, let what? Let epsilon greater than 0 be given. So we seek what? We seek a delta, or we want to find a delta greater than 0 such that if the absolute value of x minus 2 is between 0 and delta, then the absolute value of 28 over 3x plus 1 minus 4 is less than epsilon. Okay? So, working backward, that is, let's consider this conclusion to come up with appropriate delta. So find an appropriate delta, So by considering this conclusion, so let's have the left side, 28 over 3x plus 1 minus 4. And this is equal to what? If I get the LCD, I will have 28 minus 3x times 4, that is 12x, no? Minus 12x minus 4 all over 3x plus 1. Okay, guys? And this is equal to, when simplified, 28 minus 4 is 24. Factoring out 12, we have negative 12 inside. We have 12, negative 12, then x plus negative 2. So, meaning x minus 2. Let's check negative 12x. Okay. Negative 12 plus negative 2, positive 24. Okay. Absorb this all over absorb what? 3x minus, plus 1. Absolute of 3x plus 1 rather. So let's simplify this further. So I can write that as what? As absolute value of 12 times, which is 12 times absolute value of x minus 2. All over abs of 3x plus 1. So we want our abs of x minus 2 to be fairly small, no? This is what we want. We want this to be small. So we have to keep the multiplier to be small, meaning I want 12 over absolute of 3x plus 1 to be small. So how can we do that? So in order to do that, we have what? Guys. So, okay. So, and this is less than epsilon, huh? So that's what we want. And we know that this is less than epsilon. Okay, guys? So, let's now, let's bound 12 over abs of 3x plus 1. How can we do that? So again, let's bound you can have 12 over, or you can just have the 1 over, no? Abs of 3x plus 1. Yeah. So let's bound this. So since there is a possibility that I can reach in my interval that I'm going to form once I choose delta, possible that I can cover the value of x that will make 3x plus 1 0, which is not in the domain, no? So I have to be careful with that. So for me to get away from that value, I have to choose a delta in bounding this. So how far am I from what? From 2. Enough to be close to 2, but will not cover the value of x that will make the denominator 0. Can I assign delta to be equal? Can I say that delta can be equal to 1? So let's check. Or less than that. A fair value of delta that you can stipulate is 1, at most 1. No? But although you can have more than that, but that is a convenient or a better choice of delta. But let's see, it might cover the value of x that will make the denominator 0. The center is at what? At 2, no? Am I correct? The center is at 2. So I'm trying to avoid adding delta that will cover what? Negative 1/3. I am avoiding negative 1/3. So let's say this is negative 1/3. So, and let's say this is 1. Let's say this is 1. This is 3. So I'm going to have my delta. So my delta 1. If I take delta 1, possible, I can take that. So this will not cover the value of x that will make the denominator 0. Okay, so this is what I am trying to avoid. I'm trying to avoid this value, guys. That value. This is not in what? Not element of the domain, no? Of the function of my f of x. Okay? Or domain of f, not element. So I'm now safe, no? So I can now proceed. I can now stipulate my delta, no? So let's stipulate delta or take delta. Take delta to be what? To be equal to 1. I can now take delta to be 1. Okay? Yeah. In this case, the maximum delta that you can have up to what? Up to 2 minus negative 1/3, I think. And that is 7 over 3. Because if I subtract from 6 over 3, which is equal to 2, 7 over 3, that will give me negative 1/3. So this is the maximum delta that I can take. No? Let's put that so that you know. At least if you do not want x equals 1, you want it more than that. So you have so many options. No? You have that option if you want. But it's important you will able to show that for the chosen delta, you will get the absolute value of f of x minus L to be less than epsilon. So you just try to find a delta that will work. No? So delta max that you can take, meaning an upper bound for delta, is what? Is 7 hubs. That's the max that you can have. Sorry, not 7 hubs, 7 over 3 now. Because 2 means 6 over 3 minus 7 over 3. That is negative 1 over 3. Okay, but I want to take delta to be 1. You know how you have many options. You are free to choose your delta. But of course, you choose a practical delta. No? That will really make your delta small. Or, of course, any delta less than your chosen one. So, we know that abs of x minus 2, is that x minus 2? Is less than what? So I take my delta to be 1, less than 1. And if I get rid of the absolute value, it is between negative 1 and 1, this x minus 2. And I want to get 3x, no? I multiply by 3, its part. So negative 3 less than 3x minus 6 is less than 3. So from here, I want to make it plus 1. So I had to add 7. 3x plus 7, that is equal to 1. Plus 7, that is equal to 10. Plus 7 here, that is equal to 4. Am I correct, guys? Guys? If I multiply by, am I right, guys? If I multiply, let me check well. Am I correct with this, guys? Could you please check? Let me check x minus 2. Am I correct? X minus 2, okay. So it is 4x. 4 is less than 3x plus 1, right? So if I multiply this by 3, so this is 3, okay. So I take the absolute value. We now have what? 4 is less than abs of 3x plus 1 because the extreme values are both positive, no change in the sign, right? But I want the reciprocal of this. So if I take the reciprocal, so there will be change in sign, or I have to interchange the position of 4 and 10. So it is now 1 over 10. I take the reciprocal. Is less than 1 over abs of 3x plus 1, and that is less than 1/4. Is that clear, guys? So again, if I take the reciprocal of this is now 1/4 greater than absolute value of 1 over 3x plus 1 is greater than 1 over 10, or 1 over 10 is less than this fraction, and it is less than 1/4. So from there, I can now bound the fraction. So let me go back. What is that fraction? It's hard to work on problem that you don't see. So where is that? So if I move to the next slide, it's hard now. So this is what I am working now. And what is nice in this expression is that this is really the left side of what the conclusion is. No? So let me get this part. This part, which is actually the left side of the conclusion. Yan. This is, and let me remove the equality sign. Yan. Ay, sorry. Let's move a little here. Yan. So this is equal to what? Which is exactly the left side of the conclusion. Is 12 times what? 12 times abs of x minus 2. And this is times 1 over abs of 3x plus 1. Okay? And this is less than 12 times abs of x minus 2 times what? Times 1 times, am I correct? What is our bound? No, sorry. It is 1 over 4. 1 over 4. Am I right, guys? 1 over 4. Could you please check? Guys, let me check. Okay, 1/4, really 1/4. No? So this is less than what? This is less than 1/4, therefore this is greater than this. This is the same with this. And since this is less than 1/4, so this is less than this. Okay? So from there, I can now have this quantity. This is equal to 3 times abs of x minus 2. Now, since this is less than this, and this is equal to this, so, and this is not exactly this one, but I want this to be less than epsilon. Let's force this to be epsilon. So let 3 absolute value of x minus 2 to be less than epsilon. Because if this is less than epsilon, this is less than epsilon guaranteed. So if I force this again, if I force this to be less than epsilon, this is less than epsilon. I will not force this to be less than epsilon if this is exactly equal to this. But it so happens that this is greater than this. But if I force this to be less than epsilon, then this left side is less than this. I mean, is less than epsilon also. Okay? So then, what is now my absolute value of x minus 2? That is epsilon over 3. So I can now take delta to be epsilon over 3. So from there, we can now have our formal proof. So let's now have our formal proof. So that is showing that delta, which is equal to minimum, because we have two restrictions. What are our restrictions? 1 and minimum of 1 and epsilon over 3. Okay, guys? Do I have to write to emphasize that? Let me emphasize that. And let's have the formal proof here. So we have two restrictions. We have two restrictions for delta. So we have take delta to be minimum of what? 1 and epsilon over 3. Okay. So let's see if this delta, chosen delta, works. We know that the absolute value of x minus 2 is between 0 and delta. And this implies that the absolute value of x minus 2 is less than epsilon over 3. And what we got from delta equals 1 is that 1 over 3x plus 1 abs of this is less than 1/4. Okay? So combining the two, we get x minus 2 times 1 over 3x plus 1 abs of this is less than epsilon over 3. Am I correct? Times what? Times 1/4. Okay? So, and this is what? Abs of x minus 2 over abs of 3x plus 1 is less than epsilon over 12. If I multiply by 12, I get 12 times x minus 2 abs of that all over abs of 3x plus 1. And this is less than, so times 12, no? 12 times epsilon over 12. So we now get less than epsilon. Okay? But we know that the left side, this left side, is exactly the same with what? It's the same as 28 over 3x plus 1 minus 4. And we know that. So from here, so this is the same with this. Exactly equal. So I can say that this f of x minus 4 is less than epsilon. Since we have shown that f of x minus 4, absolute value of that is less than epsilon, we say that the limit as x approaches 2 of 28 all over 3x plus 1 is equal to 4. Okay, that's it. Have any question, guys, before I leave? So I think I have given you enough examples, variety of examples, making use of delta epsilon. Just informing in case I have corrections. No? So you know that it's hard to solve in a monitor, no? Using a pen tablet. Okay, guys? Okay. Bye, guys. See you for the next lecture.